A very good morning to one of you. So myself Avinash Jail, working as assistant professor in electronics and communication department, Sri Venkateswara College of Engineering, Bengaluru. So today we'll discuss about the Cmos inverter. Okay. So here Cmos, that means for complementary metal oxide semiconductor inverter. So it is, what is that particular complementary metal oxide? See, the Cmos inverter is having the combination of the PMOS as well as NMOS. Okay, so PMOS as well as NMOS, it is a combination. So when you're talking about the PMOS and NMOS combination, so you can see the diagram. Okay, so we'll go to the basic properties. Okay, what is the basic property? So here, when you're talking about the PMOS, in that PMOS, the body should be connected to the VDD. We're going to connect. Okay, to the VDD. And when you're talking about the NMOS, the body should be connected to the ground. That particular ground concept also we have been taken into consideration. After that, okay, the gate terminals are there, no? So the gate terminals we are taken as the input terminals. So in that particular thing, the A is the input, and we're taking the output as Y at the other end. Is it clear to you? So now, source to drain. That means what? The concept, the current will flow from source to drain. So now, this is the structure of the CMOS inverter. This is a very, very important thing. So on the top side, where the VDD is being connected, we are going to connect the PMOS. In the bottom side, where the ground will be connected, that is called as what? NMOS. PMOS as well as NMOS will be taken into consideration. Is it clear to you? So A will be the input and Y will be the output. Clear. So now what the inverter will do? Inverter will take the input and will invert the output. That means what? If you give the A as 0 and output Y will be equal to 1. How it is going to 1? We'll see. So let us consider first we'll pass the 1. Okay, when we're trying to pass 1. So we know that, okay, so your PMOS will be like a complemented one and NMOS will be the normal one. Okay, so when 1 is been sent, okay, so obviously the 1 will be sent to the gate of the PMOS and the same one will be sent to the gate of the NMOS. The gate will be open. Okay, gate will be open for NMOS and gate will be closed for PMOS. When the gate is been closed to the PMOS, okay, so what will happen? The VDD will not able to flow. When the current is not flowing, definitely Y will be 0. Y will be 0 even though NMOS is on. Even though NMOS gate terminal we are getting the supply, the VDD is cut off. That is why we will not get the output. Is it clear to you? So I can say that when the A equal to 1 is been given to you, okay, so VDD will be off and PMOS will be off and NMOS will be on. PMOS will be off and NMOS will be on. So the output is 0. The output Y equal to what? 0. Is it clear? So A is 1. So when the 1 has been fed, the PMOS will be off and NMOS will be on. Output is eventually it will be 0. Why? Because VDD will not carry in the PMOS. When the VDD is not carrying in the CMOS, definitely output will be 0. Is it clear to you? That's the thing. So now we'll go to the next condition. We'll pass the 0 for the gate. When you are sending the 0 to the gate, what will happen? What will happen when you're passing the 0 to the gate? Okay, so obviously PMOS will be on. Okay, I'll show you that particular thing. You can see that the PMOS will be on and NMOS will be off. Clear? PMOS will be on and NMOS will be off. Okay, so when the PMOS is on, VDD will definitely flow. When the VDD is definitely flowing, Y will be equal to what? 1. Y will be equal to what? 1. And the NMOS is off, so there is no current which is flowing through the NMOS. Okay, I can say that output equal to 1. You can see in the tabular column. Okay, truth table you can able to see where A equal to 0, Y equal to 1 we got, and where if A equal to 1 and Y will be equal to 0. That is what exactly operation of this particular CMOS inverter. How it works, I explained here. I think you people are understanding this particular concept. Okay, how the CMOS inverter is working. So the symbol, when I'm talking about the symbol, you can understand very clearly. Okay, so symbol is very simple, the same like your inverter. Okay, so the same like your NOT gate. Okay, so the NOT gate operation with respect to the MOSFET technology, with respect to the CMOS inverter, we have discussed this particular thing. I hope that you people have understood this particular concept. Okay, I repeat once again. So we'll go for the first thing, that is when A equal to 1, what will happen? The PMOS, which is at the top, will be off, and NMOS, which is at bottom, will be on. Since the top is off, VDD will not flow. The output is 0. Next condition, when A equal to 0, you can see, so PMOS will be on and NMOS will be off. That means our top transistor is on, VDD will pass through it, and output will get from that VDD. That means our current is flowing, output will be equal to 1. So I can clearly tell that when we are giving the 0, output will be 1, and when I'm giving the 1, output will be 0. Definitely it is acting as a inverter, and this particular inverter operation we have made by using the CMOS circuit. That is why it is called what CMOS inverter. Okay. So similarly, in the CMOS NAND gate, for example, after the understanding of CMOS inverter, so if you are understanding the CMOS NAND gate, okay, how the NAND gate of CMOS will be working. So this is a circuit. We can understand that this is a circuit for CMOS NAND gate. There you can see that 0, 0 is the input. Okay, so first condition, if you take 0, 0 is the input. So obviously, if the 0 is given to the PMOS is what? On, top is on. Okay, and the bottoms are two NMOS transistor off. So output is what? NAND gate. Okay, so output is what? 1 will get. So for 0, 0 input, the output is 1. Similarly, we can say that when you're talking about the 0, 1 combination, here what exactly happen? A is 0. That means what? One PMOS is on, and the second PMOS is off, and similarly one NMOS is on and another one NMOS is off. So eventually, due to the one particular diagram, one particular PMOS transistor is on, the current will flow, VDD will flow, output will be equal to 1. Similarly, the same case for respect to the 1, 0 also. Same thing will happen when 1, 1 is given. VDD to pass to the output, both PMOS transistors are off. When the both PMOS transistors are off, so definitely current will not flow from the VDD will not flow. So when the VDD is not flowing, the output is equal to 0. So that is the operation of CMOS NAND gate. Okay. So that is why I can clearly say that, okay. So in the CMOS NAND gate, you can understand one thing very clearly. So PMOS transistors, two PMOS transistors should be connected in series, and two NMOS transistors should be connected. Sorry, PMOS transistors should be connected in parallel, and NMOS transistor should be connected in the series. When you connect NMOS transistor in series and PMOS in parallel, definitely will work as a CMOS NAND gate. So it is getting the exactly NAND operation. Okay, so thank you for listening.